Hi everyone, it's Miss Costa here, and in this video we're going to go through the Edexcel paper 3 for the November 2022 series. So in this first question, I'm being asked to make A the subject of the formula. So at the moment, the subject is P. The subject is literally the variable that is on its own on one side of the equal sign. So I want to get this formula into the form A equals. So what I want to do is rearrange it by moving things from one side to the other by doing the inverse function. So the first thing I can do is think to myself, what is happening algebraically in order to know what order I do things in. So A is being multiplied by 3 and then I subtract 9. So I then need to do the inverse. So the first thing I need to do is add 9 to both sides. So I'd be left with P plus 9 equals 3A. And then what does 3A mean? It means that 3 is being multiplied by A. So I'm going to have to divide by 3, so that cancels out. And I then divide this side by 3 as well. So I'm left with P plus 9 over 3 equals A. So when you're dividing more than one term by something, just write it as a fraction. So my final answer would be A equals P plus 9 over 3. So in this question, I'm told that Rob has been asked to divide 120 into the ratio 3 to 5. Now, what do I do when I divide into a given ratio? I think about what it's actually asking me to do. I want to split 120 in the ratio 3 to 5. So for every 3 parts or 3 of whatever it is that I'm giving out to one person, I'm going to give 5 to another. So in total, each time I'm sharing my ratio, I am sharing out 8 parts. So what he should have done is do 180 divided by 8, which is 15. That tells me what the value of one part is. So if I know that one part is 15, then I can fill that in, and 15 times 3 is 45, and then 5 times by 15 is 75. So his ratio should have been 45 to 75. How do you know if you've done it right? Well, your answer should add up to the original. So 45 plus 75, that gives me 120. So I know I've split it in the correct ratio. So what has he done wrong? Well, he divided by 3, which is just dividing 120 into 3, and then he divided 120 into 5 parts. So he's doing 2 separate things. You want to bring together the parts and divide it by the total amount of parts. So Rob should have divided by 8 is the mistake that he made. Okay, so in this question, I have been told that 200 students chose one language to study. Each student chose one language from either French, Spanish, or German, and then I'm told information about these students. So I know that each student has a choice to study French, German, or Spanish. And then what other information do I know? I know that out of these 200 students, 90 are boys and the rest are girls. So I know that the options are to study French, German, or Spanish, and that if you studied French, German, or Spanish, you are either a boy or a girl. So I can just set up a table for myself, which allows me to see what's happening. So I know that 90 of all of the people that study, of all of the students, are boys. So I can fill in my totals column here. So you're essentially constructing a two-way table for yourself. So I know 90 are boys and the rest are girls. Well, what's the total of all of the students? The total is 200. So if there are 90 boys, I know that that must mean that there are 110 girls. I'm then told that 70 chose Spanish. So in total, 70 students chose Spanish. I then know that 60 of the 104 students who chose French are boys. So how many students studied French in total is 104, and 60 of those are boys. So I can figure out how many are girls. If there's 104 in total, 104 take away 60 is 44. I'm also told that 18 girls chose German, so I can fill that in here. And that is all the information that I have so far been given. So now it's kind of just like figuring out the missing pieces. If I look at my totals column, I know that the total amount of students that study French, German and Spanish must sum to make 200. So 200, take 104, take away 70, leaves me with 26. So I know the total amount of students that study German would be 26. I then have only one missing piece of data here. I know the total amount of students that study German is 26. 18 of these are girls. So 26, take away 18, leaves me with 8. And then I'm just left with two other columns. I know that there's 90 boys in total. 60 study French and 8 study German. So if I did 90, take away 60, take away 8, that leaves me with 22. I could fill out the last little missing piece just by doing 110, take 44, take 18, which leaves me with 48, and then my full two-way table is complete. But I'm being asked to work out how many boys chose Spanish. So all I need to do is get to this part here where I figure out how many boys chose Spanish, and that would be 20. Okay, so in this question, I am told that Karina has 4 tanks on her tractor and that each tank is a cylinder with diameter 80 centimetres and height 160 centimetres. I'm told that the 4 tanks are to be filled completely with a mixture of fertiliser and water, and the fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser, and does she have enough fertiliser for the 4 tanks? So the first thing that I want to do is figure out what the total volume of the tanks are. So how do I work out the volume of a cylinder? Well, to work out the volume of any prism, what you want to do is work out the area of the cross section, and you multiply that by the length or the height or whatever you call it, the bit that isn't involved in the area of the cross section. So what's the area of this cross section here? That's a circle. The formula for the area of a circle is pi r squared. So I know that the diameter of this circle is 80 centimetres, and a diameter is 2 lots of the radius, so therefore the radius must be 40 centimetres. So I can just substitute that into my equation. So the area is going to be pi times by 40 squared. Now I can just leave that in terms of pi for now because I'm not being asked to round anything yet. I only want to round at the very end. So 40 squared is 1,600. So that area of the top part is 1,600 pi. Now what do I do to work out the volume? Well, I work out the area of the cross section, which is 1,600 pi. And then I multiply it by the length, which is 160. So 1,000, so the volume is going to be 1,600 pi times by 160. And 1,600 pi times by 160 gives me 256,000 pi. Now that's the volume of one cylinder, and I have 4 cylinders, so I'm going to multiply that by 4, which leaves me with quite a large number, 3,216,990.877 centimetres cubed. Now I've been given a vital piece of information, which is that 1 litre is equal to 1,000 centimetres cubed. And that's because 1 millilitre is equal to 1 centimetre cubed. So what I want to do to turn my centimetres cubed into litres, I'm going to divide by 1,000 to get it to litres. So divided by 1,000 gives me 1,024 pi. So I know that the total volume of all 4 cylinders is 1,024 pi. I could convert it into decimals if that makes life easier for you. So that would be 3,216.990,877 litres. Now I know that the fertiliser has to be mixed with water in the ratio 1 to 100. So 1 part fertiliser to 100 parts of water. So in total, I have 101 parts. So what I want to do to work out how much fertiliser I need is divide by 101. And that gives me 31.6 31.85139,482. So I need 31.85 litres of fertiliser in order to fill these tanks correctly. She has 32 litres of fertiliser, so I would say yes, she has 31.85 litres, which is enough. So in this question, I'm told that triangle ABC and DEF are similar. Now, when shapes are similar, that means that they are an enlargement of one another and that they are enlarged by a scale factor. And the scale factor is just a number that the shape is enlarged by. So for instance, let's imagine that this was 8. If I multiply 4 by 2, that gets me 8. So the scale factor would be 2. So scale factor is just how many times larger is one shape in comparison to the other. So what I want to do is find two sides that are corresponding to each triangle. So I know that this angle here is equal, so angle B is equal to angle E, and angle C is equal to angle F. So I know those two base angles are equal. Therefore, these sides here must be equal. So I want to think to myself, how many times larger a shape, the larger triangle, than the smaller one? Well, 5 times by what gets me to 20. 20 divided by 5 is 4. So I know that 5 times 4 gets me to 20. So the scale factor of enlargement is 4. So to get from my smaller shape to my larger shape, I just multiply each of the sides by 4. Now I want to work out the length of EF, which is this side here, and what's its corresponding side on the smaller triangle, this side here. So what do I do to get from the smaller triangle to the larger triangle? I multiply by 4, and 4 times 4 is 16. So the length of EF is 16. I then need to work out the length of AB. AB is this length here, and I know the corresponding length on my larger shape. Now, if the scale factor of enlargement to get from your smaller shape to the larger shape is you multiply by 4, that must mean that to get from the larger shape to the smaller shape, you divide by 4, because this shape is 4 times smaller. So I'm going to do 22 divided by 4, which is 5.5. So the length of AB is 5.5 centimetres. So in this question, I've been given a probability tree. I'm told that one weekend, the Keddy family is going to do a sports quiz and a music quiz. The probability that the family will win the sports quiz is 0.3, and the probability that the family will win the music quiz is 0.35. Now, the key thing with probability is that it always sums to 1. So the probability of something happening and the probability of something not happening must make up 1. Like if the probability of it raining tomorrow is 70%, the probability that it does not rain is 30%, because the only option is rain or not rain. So bearing that in mind, when you've got a probability tree, your branches must also always sum to 1. So I know that if the probability that the family will win the sports quiz is 0.3, the probability that they do not win must be 0.7, because 0.3 plus 0.7 gives you 1. So I can fill that in here. I do the same for the next part. So the probability that they win the music quiz is 0.35, and 0.35 plus 0.65 gives me 1. So I can fill that in over here. So you always want to double check that your branches, each individual little branch, sums to 1. Now, I've been asked to complete the probability tree diagram, which is what I've done just by figuring out what the missing piece is by getting both of my branches to sum to 1. And for the next part, I am being asked to work out the probability that the Keddy family will win both the sports quiz and the music quiz. So I think about what route can I take along my probability tree? Well, if I win the sports quiz, I go along this branch. And if I win the music quiz, I go along that branch. Now with probability, to work out the probability of, let's say, X and Y happening, you always multiply the probabilities. So when you go along your branches, you multiply. So I'm going to do 0.3 times by 0.35, which leaves me with 0.105. So that would be the probability that they win both. So in this question, I'm being asked to convert 8,000 centimeters cubed to meters cubed. Now, a question like this is really frequently just done wrong because people rush through this and they know that 1 meter is equal to 100 centimeters. So they're like, oh, I'll just divide it by 100. But let's think about what's actually going on. So if I just think about lengths to begin with, so 1 meter is equivalent to 100 centimeters. But that's only when I'm dealing with lengths. When I deal with area, it gets a little bit more complicated. So if I think about it, 1 meter by 1 meter, that gives me 1 meter squared. But when you think about it in terms of centimeters, 1 meter in centimeters as a length would be 100 centimeters. So 1 meter squared is equivalent to 100 centimeters by 100 centimeters, which is 10,000 centimeters squared. So even though 1 meter equals 100 centimeters, when it comes to area, 1 meter squared is actually 10,000 centimeters squared. And when it comes to volume, it gets even larger. So think about it again. If you've got a cube that is 1 meter by 1 meter by 1 meter, then that would be 1 meter cubed. But if we do the same for centimeters, and that was 100 centimeters by 100 centimeters by 100 centimeters, I'd have to work out the volume by doing 100 times 100 times 100, which is 1,000,000 centimeters cubed. So you can just memorize these and know that 1 meter cubed is equivalent to 1,000,000 centimeters cubed, but it's also good to think about why this is happening. So now that I know that 1 meter cubed is 1,000,000 centimeters cubed, what do I do to go from centimeters cubed to meters cubed? Well, to get from 1,000,000 to 1, I divide by 1,000,000. So that's what I'm going to have to do to 8,000. So 8,000 divided by 1,000,000 is going to give me 0.008. So that is how I would do that question. So take real care whenever you're dealing with centimeters squared to meters squared and centimeters cubed to meters cubed. So another converting metric units question, I need to change a speed of 180 kilometers per hour to meters per second. Okay, so there's a few things I need to think about first. First, I want to change 180 kilometers into meters. So how do I change kilometers into meters? I know that 1 kilometer is equal to 1,000 meters. Therefore, to get from kilometers to meters, I multiply by 1,000. So 180 kilometers is going to be 180,000 meters per hour. So all I've done is turn my kilometers into meters. So I know the speed is 180,000 meters per hour, but I want to get it to meters per second. So I know that in 1 hour, there are 3,600 seconds because there are 60 minutes and 60 seconds in a minute. So how do I get hours to seconds? I divide by 3,600. So I'm going to need to do the same over here. 180,000 divided by 3,600 gives me 50 meters per second. Okay, so in this question, I'm told that there are 30 women and 20 men at a gym, and the mean height of all 50 people is 167.6 centimeters. So how do I work out the mean in general? I add all the values together, so the sum of all of the values, and I divide it by the number of values that I have. So the overall mean, I know, is 167.6, and that's going to be the sum of all of the heights divided by 50, because I know that there are 50 people in total. So what can I do to figure out what the sum of all of my heights must be? I can do 167.6 times by 50, because I just multiply both sides by 50. And that would give me 167.6 times by 50 is 8,380. So I know that all of the heights of all of the people in the gym added together comes to 8,380 centimeters in total. Now I'm told that the mean height of the men, so once again, mean is 20, equals the sum of the values, so the total heights of men, divided by 182. So how could I work out the total heights of the men? I'd do 20 times by 182, and that would give me the total heights of the men as being 3,640. So if I know that the total heights of everybody sums to 8,380 and that all of the men, their heights sum to 3,640, I can subtract that to figure out what the total heights of the women must be. So 8,380 take away 3,640 gives me 4,740. So I know that the total heights of the women must be 4,740. And I need to work out the mean height. How do I work out the mean? Well, it's the sum of all the values. So the sum of all of the heights of the women, which is 4,740. And I divide that by the number of women, the number of values, which is 30. So 4,740 divided by 30 gives me 158. So that would be the mean of the women. So in this question, I'm being asked to write 6.75 times 10 to the power of negative 4 as an ordinary number. And all an ordinary number means is just a number on its own, not being multiplied by anything. So 6.75 is being multiplied by 10 to the power of minus 4. And there are two ways to do this. One is just by counting the decimals, but one is by actually understanding what 10 to the power of negative 4 is. So if I just think about all of my powers of 10, I know that 10 squared is 100, 10 to the power of 1 is 10, 10 to the power of 0 is 1, because anything to the power of 0 is 1. So what's happening each time? Well, each time I'm dividing by 10. So what would happen when I got to negative 1? I'd have to divide by 10 again. So 1 divided by 10 is 0.1. What would I do next? I would have to divide by 10 again. What would I do next? Divide by 10 again. What would I do next? Divide by 10 again. So 10 to the power of minus 4 is 0.0001. So I can do it like that and multiply it like a decimal. Or what you can do is think to yourself, okay, so I've got 6.75 and it's multiplied by 10 to the power of minus 4, which tells me that my number is going to start 4 digits after the decimal point, or you can do it as how many zeros are in front of the start of your number. So 6.75 times by 10 to the power of minus 4. I start my zeros. I've got 0, that's 1, 2, 3, 4 zeros, and then I start writing my number. So that's the cheat way of how to do standard form. Proper way is, well, not cheap, shortcut. Understanding 10 to the power of minus 4 is 0.0001 and doing the multiplication that way, whichever way works best for you. Okay, so here we've got a calculation that involves numbers that are written in standard form. And because it's a calculator paper, I can just type this whole thing into my calculator. And then I come up with this answer. So that whole calculation gives me 659,200. Now it says, give your answer in standard form. So what I need to do is think to myself, okay, to write a number in standard form, I need to write it as a number between 1 and 9.9 times by 10 to the power of something. So to turn that into a number between 1 and 9, I'd write it as 6.592 times by 10 to the power of, and once again, if you get a little bit stuck, just think to yourself, well, 6 times by 10 is going to give me 60, times by 100 would give me 600 times by 1,000, would give me 6,000 times by 10,000, would give me 60,000 times by 100,000, would give me 600,000. So you can use that as an estimate. So you know you're trying to times by 100,000. And then this is just if you're getting stuck with standard form, you know that timesing by 10 is 10 to the power of 1. 10 squared is 100. 10 cubed, 10 to the power 4. And 10 to the power 5 would be 100,000. So that would be 6.592 times 10 to the power 5. The shortcut way is you just count how many digits are before your first digit. So 1, 2, 3, 4, 5. You choose whichever method works best for you. Okay, so here is an algebraic subtraction, and this is actually something that people really frequently get wrong when they're doing algebraic fractions. So let's have a look at what's going on. So Peter has to subtract this from x squared plus 3x plus 5. So let's write x squared plus 3x plus 5, and then I am subtracting this whole expression. Okay, so the key thing here is I am going to be subtracting x squared, but then I'm going to be subtracting negative 2x. So what he has done here is he's just assumed you're subtracting everything, and he's not paid any attention to the fact that you're going to be subtracting something twice. And when you're subtracting a negative, it's the same as adding. So what he should have written is minus x squared plus 2x plus 4. Now, if this is a little bit confusing for you, then when you're subtracting a whole expression, just put a little a negative 1 in front of your bracket, and then just expand the brackets. Negative 1 times by x squared gives you negative x squared. Negative 1 times by negative 2x would be plus 2x. And negative 1 times by negative 4 is positive 4. Remember that the term always, the sign always belongs to the term after it. So what has Peter done wrong? He should have added 2x plus 4 instead of subtracting. He didn't take into account that subtracting a negative leads to a positive. So in this question, I have been told that x and y are integers such as 3 is less than x, which is less than 8. So I could just draw myself a quick little number line. I know that the x values have to be between these two values, but not including them. Remember, if a sign looks like this or like this, it means less than or greater than. And if they have the little equal sign underneath them, it means they can be equal to. So this could be less than or equal to, and the other signs are just going to be less than or greater than. Okay, so I know therefore that my integers for x cannot be 3 or 8. So my x values could be 4, 5, 6 or 7. So any of these values. Now let's do the same for y. So a number line with 4 and 10. Again, it's this sign that's been given. So that means 4 is less than y, which is less than 10. So the values that it could be would be 5, 6, 7, 8 and 9. So my y values could be 5, 6, 7, 8 or 9. Now I am told that x plus y equals 14. So therefore I can only have variables that add together to make 14. So if x is 4, is there a y value that would contribute to make 14? No. So x cannot be 4, because the only way to make 14 with 4 is 4 plus 10, and 10 is not a possibility. Let's try with 5. If x is 5, then y would be 9, because 9 plus 5 makes 14. Now let's try with 6. So if x is 6, 6 plus 8 gives me 14. So that could also work. And if x is 7, y could be 7. Is there anything else that would work? Well, if x, we've run out of x values, so if y is 6, what would I need x to be in order to get to 14? It would need to be 8. So that would not work, and that would not work. Okay, so all I need to do is find the possible values of x, which would be 4. Nope, it would not be 4. It would be 5, 6, and 7. So 5, 6, 7. Okay, so here we have a slightly sneaky question. We're told that Martin used his calculator to work out the value of the number p. He wrote down the first 2 digits of the answer on his calculator. Now, this is really important. It doesn't say that he did any rounding. He just looked at his calculator and he wrote down the first 2 digits. So he wrote down 1.2. And we need to complete an error interval for p, which means we need to figure out the minimum possible value that it could have been and the maximum possible value that it could have been. Now, if we look at the error interval, it's given in the form something is less than or equal to p, which is less than the greatest value. So this, it could be something larger than the value that we see in the calculator. But let's have a think. If on the calculator you saw the digits 1.2, the smallest possible values that could come after it would be 0.0000000. That's the smallest value that it could be. So 1.2 would be the minimum value. And if we think about the maximum value, well, what's the largest digit that could come next to the 2? It could be 9, then 999999999. So that would be the technical 1.29 recurring would be the technical maximum value, but because with the error interval, they have not given us is less than or equal to, they've just said it has to be less than, we would write 1.3. However, if that's confusing and you wrote 1.29, you would still get the marks. This is technically the correct thing. That is the largest value it would be. It's just because the error interval is written in the way such that it has to be less than the maximum value. And just a quick note, what this is called is truncation. And truncation is where you literally just chop off the digits. You ignore everything else. You don't do any rounding. You just truncate. So it's different to normal where they've given you a rounded value and then you have to like find that midway point. You need to just look at it and think, okay, they've chopped it off. They've disregarded anything else. I just know that the first 2 digits are 1.2. So it's the minimum possible value and the maximum. So in this question, I've been given a cumulative frequency graph with its corresponding table of values. Jen draws this cumulative frequency graph for the information on the table, and I need to write down 2 different things that are wrong with this graph. So let's start by looking at the axes. I know that the y-axis, even though she hasn't labelled it, is the cumulative frequency, but I don't know what the x-axis represents. So the first thing that I would say is that she hasn't labelled the x-axis. You could also call it the horizontal axis, but she hasn't told us what that represents. It should have been time. Okay, next let's have a look. So whenever you plot a cumulative frequency graph, you always plot it against the x value and the cumulative frequency. So your x value is always going to be the upper end of the class interval. So let's see if she's done that. So the first coordinate should have been 10, 4. Has she done that? So 10, 4 would be over here. No, she hasn't. What has she done? She has plotted against the midpoint instead of the upper class interval, or the top end. Okay, so instead of the top end of the interval. You always, when you're doing a cumulative frequency graph, always use the highest value as your x coordinate. Okay, so here I've just got a calculation that's been multiplied to the power of 4. Now, if you're not 100% and you sometimes forget your index laws, the best thing to do is to think about what is the algebra actually doing. What does to the power of 4 mean? It means multiplied by itself 4 times. So what I could do is actually write this out. So let's just split it up, because whenever we're dealing with algebra, there's always a little invisible multiplication sign between each term, or each part of the term. So I know I've got that times by 3 times x to the power 5 times by y to the power 6 times by 3 times x to the power 5 times y to the power 6, and then again times by 3 times by x to the power 5 times by y to the power 6. So when I have it laid out like this, it makes it a little bit easier to see what I need to do. Now, if you're not 100% sure on your multiplying with indices, that's probably something you want to get familiar with. Worst case scenario, what you could do is you could write everything out like this. So x to the power 5 means x multiplied by itself 5 times, and then write out y as well. But hopefully we know the law of multiplication is that when I am multiplying indices, so x to the power of 2 times by x to the power of 5, I add them. So that would become x to the power of 7, because what does x times x mean? It means x times x, and then x to the power of 5 means x times x times x times x. So in total, you are multiplying x by itself 7 times. So law of multiplication is one we definitely need to know. And then what I can do is see that I am multiplying 3 by itself 4 times. Okay, so 3 times by 3 times by 3 again, and times by 3 again. 3 times 3 is 9, times by 3 is 27, times by 3 is 81, but you've also got a calculator, so use that to your advantage. So I know it's going to be 81. Then let's deal with the x's. So x to the power 5 times by x to the power 5 times by x to the power 5. What do I do? Well, that becomes 5 plus 5 plus 5 plus 5 is 20. And the law of brackets, so if you want the shortcut way, the law of brackets is that each of these things are going to be done to the power of 4. So 5 times 4 is 20, and 6 times 4 is 24. So the law of brackets, I'll just write it up here. The law of brackets is that you multiply the indices together when they're in a bracket. Okay, so you multiply the powers. But sometimes people get confused by this, and also sometimes they forget to multiply just the number by itself, so they forget that 3 needs to be to the power of 4 as well, which is why it's helpful to just write out what's happening with the algebra. But anyway, let's finish this off. So we've got y to the power of 6 times y to the 6, y to the 6. So 6 plus 6 plus 6 plus 6 is 24. Okay, so I've done a few ways that you can do this. Obviously, the quickest way is the law of brackets, but just remember, be mindful that you're also doing 3 to the power of 4. Okay, so this is expanding a triple brackets question, which should technically be pretty straightforward, but the amount of people that get this wrong is unbelievable. So I'm going to show you a way that will help just not miss any tiny little parts out, because when we're dealing with so much multiplication, it's really easy to just miss one little bit out. So what we can start with is just by multiplying our first 2 brackets, which we should be pretty confident with. We're just multiplying double brackets. So x times x is x squared, x times minus 3 is minus 3x, 2 times x is 2x, and 2 times negative 3 is minus 6. We can simplify that. So minus 3 plus 2 is minus 1. So my first bracket, I know, expands to this. So this expands to make this. Now the next part, so once we're dealing with the third bracket, the best thing to do is to put it in a grid, because the amount of people that just miss one term out by accident is unbelievable. So you've got x squared, you've got minus x, and then you've got minus 6. And I should have done the grid a little bit bigger. And then on the other side, we do the final bracket. So x plus 4. And now all we need to do is multiply it in the little grid. So x times x is x cubed, minus x times x is minus x squared, x times minus 6 is minus 6x, x squared times 4 is 4x squared, minus x times 4 is minus 4x, and minus 6 times 4 is minus 24. Okay, so you've got all of your terms, and the cool thing about the grid method is that your diagonals are always going to simplify. So you can write it all out. I mean, you can write it all out bit by bit, or you can just simplify as you go along in your diagonals. So 4x squared take away x squared gives you 3x squared. And then minus 4 minus 6 is minus 10. And then you're left with minus 24. So the final bit, the final answer, as you can see, is just a little bit easier to bring the terms together, because the amount of people that just miss one term or simplify one, or one of the negatives gets in the way, this literally guarantees that you're going to get it right. Okay, so in this question, I'm told that a pet shop has 7 guppy fish, 13 tetra fish, and 5 angelfish. And David is going to choose one of the following combinations of fish: a guppy fish and an angelfish. So let's just have a quick little recap of the and the or rule. If you're trying to work out the probability of this and that happening, of 2 things definitely happening, then you multiply your probabilities. If you're trying to work out the probability of this or that happening, you add your probability. So for instance, if I knew that the probability that it was going to rain tomorrow was 65%, the probability of it not raining tomorrow would be 35%. So if I were to want to know what the probability of it raining or not raining is, I'd add them together, and of course they make 100% because you're having more things in the mix. So the or rule, you always add your probabilities, and if you're trying to work out the probability of this and that happening, there's more things that are at play, so the probability generally gets lower, so we multiply. So what's the probability of a guppy fish and an angelfish? So a guppy fish, there are 7 guppy fish, and there are 5 angelfish. So 7 times by 5 is 35. So I have 35 combinations, 35 possible options, because each guppy fish, so let's just say guppy 1, guppy 2, guppy 3, 4, 5, 6, 7. Each of these little guppy fish I can combine with angelfish 1, angelfish 2, angelfish 3, angelfish 4, angelfish 5. Okay, so when I'm doing combinations, I have to use the product rule, so the multiplication rule, because with each individual guppy fish, I have 5 options. So I have 7 guppy fish and 5 options for each of those guppy fish. That's why I do 5 times 7. So people sometimes get confused about it, but if you think about what it actually means, each individual fish can be combined with each individual other fish. So it looks like this strange little tree like that. Then he could have a tetrafish and an angelfish. So a tetrafish and an angelfish. How many tetrafish are there? There are 13 tetrafish. So each of these 13 fish could be combined with an angelfish. So there are 5 angelfish, and 13 times by 5 is 65. And finally, we've got, he could get a guppy fish, a tetrafish, and an angelfish. So he could get a guppy fish, combine that with any of the 13 tetrafish, and combine that with any of the 5 angelfish. So what's that? 7 times by 13 times by 5 is 455. So if he just gets a guppy fish and an angelfish, he has 35 combinations. If he gets the second option, he has a total of 65 combinations, and for the last one he has 455, so we just do 35 plus 65 plus 455 equals 555. So that is how there are 555 different ways for David to choose his fish. Okay, so in this question I have been given a circle with a cyclic quadrilateral, and the whole weird shape forms a large triangle. So always try and visualize to yourself what shapes are actually formed, because that helps you later on. So first of all, I'm told that A, B, D, E is a cyclic quadrilateral, and that's important because if it's a cyclic quadrilateral, I can use the circle theorems. Now, in order for something to be a cyclic quadrilateral, it just means that each of its vertices of the quadrilateral need to touch the circumference of the circle. So if they hadn't told you that, you could have figured it out yourself by just thinking to yourself, okay, each of the vertices touch the circumference of the circle. So that's an important thing that we can use later. I know that ABC and EDC are straight lines, and I'm told that angle DBC is 60 degrees. So let's first have a look at what we can work out from here. So I know that this is a straight line, therefore I could work out this angle here. So angle ABD must equal 120 degrees, as angles on a straight line sum to 180 degrees. Now, because this is a circle theorem question, anything that has angles or circle theorems, you're going to want to show all of your working and all of your reasoning. So all of the angle rules that you know. The only way you could have figured out that this angle is 120 is by knowing that angles on a straight line add up to 180 degrees. So just write it down. The next thing we can do is we were told that this is a cyclic quadrilateral. Now, in a cyclic quadrilateral, opposite angles sum to 180 degrees. So in a cyclic quadrilateral, opposite angles sum to 180. So I could figure out what this angle here is. Therefore, angle AED must equal 60 degrees. So I know that angle is 60 degrees. And then what other information have I been given? Well, I'm told that the size of angle EAB, so this angle here, to the size of angle BCD is 2 to 1. So whatever the size of angle BCD is, if that was X, this would be 2X. So I could label that accordingly. This is X and this is 2X. Now, the next part, so you've done like all of your working out from all of the information that you've been given, and this is the bit that catches most people out. You just want to try and visualize to yourself, okay, so I've sort of worked out everything I can within the cyclic quadrilateral. I've done my straight lines. I can't see anything further that I can do. So let's just have a look at what happens if I just zoom out and take a bigger picture. I know that there's a triangle that's formed. So I have this triangle over here. That's got the angle X, which is the angle I'm trying to work out. I know this is 2X, and I know that this is 60 degrees. So you then have an angle, and we know that angles in a triangle sum to 180. So that would be our next rule. So angles in a triangle sum to 180 degrees. You can form an equation using the ratio parts that you've been given. So X plus 2X plus 60 degrees must equal 180. Therefore, 3X plus 60 equals 180. Therefore, 3X must equal 120, and X must equal 40 degrees. So the last part, and the bit that kind of catches most people out, is just zoom out and think to yourself, okay, I've got a cyclic quadrilateral, but how can I look at all of the other lines? Oh, that's a giant triangle. So let's use that. So in this question, I've got one of the trickier kind of a ratio questions. So let's have a look at what's going on. I'm told that there are 4 boxes on a shelf, A, B, C, and D. And the total weight of A and B put together is 3 times the total weight of C and D put together. So I know that the weight of A and B must be 3 lots of the weight of C and D. So I could just write that algebraically, or I could just leave it as 3 to 1. It doesn't really matter. So I know that whatever the weight of A plus B added together is, it must be 3 times the weight of C and D. So I need to keep splitting it into that ratio. Now the next piece of information I'm given is the weight of A is 2/3 the weight of B. So out of this ratio here, I know that whatever the weight of B is, so we could call B X, the weight of A is going to be 2/3 of that. So 2/3 of X plus X, which I could actually write as 3/3, just so that you maybe see what's going on, because X is a whole thing, value. Whatever B is the value that I'm relating to. A is going to be 2/3 of it. So if B was 30, A would be 20. But I'm just calling it X because I don't know the value. You can substitute values if you want to, as long as you keep it constant. So I know that 2/3 of X plus 3/3 of X, or a whole X, must equate to 3. So therefore 5/3 X must equal 3. And how could I figure out what X is? Well, I divide both sides by 3. So 3 divided by 5/3 gives me 9/5. Okay, so either, I'm trying to think, I'll leave it in fraction form. So I know that if X is 9/5, then I'll write it in all forms actually. The value of A, the value of B, the value of B would be 9/5 or 1.8. And then times that by 2/3 to figure out the value of A. That would be 6/5, or in decimal form, 1.2. So I figured out what the ratios of A to B must be. And that would be 1.2 to 1.8. So I've just broken that up into 2 parts, 1.2 to 1.8. And that is the ratio of A to B. Now what I want to do is do the same, but with this part here. So I know that the weight of C and D is going to be 1 part of whatever A plus B is. So I know that the weight of C is 75% the weight of D. So therefore, 75% I can write as 3/4. So if I give my value of D an algebraic form, so I'm just going to call dx because that's the value that I'm working with that I know as a whole. So if D is X, then C would be 3/4 X. And once again, I could write this as 4/4 X because what's 4/4? That's a whole. So it's the same thing, but just so you see what's going on. So 3/4 X plus 4/4 X must equal to 1. Add them together, 7/4 X must equal to 1. So therefore, how am I going to work out what X is? I'm going to divide both sides by 7/4, which leaves me with 4/7. So therefore, C and D, well, D must equal 4/7, or if I type that into my calculator, 4/7 is probably going to be, yeah, so 0.57142. It's not a nice easy decimal, so I'm going to leave it in fraction form. And then 3/4 of 4/7 is going to give me 3/7. And once again, that's probably going to be a long decimal. So I'm going to choose to keep this in its fractional form. So let's rub this out, and I've got all of my key values here. I know that A to B is 1.2 to 1.8, or I could write it in fractional form, 6/5 to 9/5. And then C to D must be 3/7 and 4/7. So I've got all of my ratios in this form in a way that they relate to each other, because I started by splitting them up into the ratio 3:1. And then using this ratio, I split them up into their A and B and C and D correspondence. So now this is the full ratio. However, it doesn't actually say to simplify it, but we're going to do that anyway. So let's just have a go at seeing what we'd need to do. So A to B to C to D is 6/5 to 9/5 to 3/7 to 4/7. Now, in order to simplify this, I want to turn them all into whole numbers. And what's the best way of turning them into whole numbers? Just multiply by the denominator. So let's start by multiplying the whole ratio by 7. So 6/5 times by 7 is going to give me 42/5. 9/5 times by 7 is going to give me 63/5. And then the reason I've multiplied by 7 is because if I multiply anything by its denominator, or its reciprocal of the denominator, look what happens. So 3 times 7 is 21, divided by 7 ends up with 3. So I basically eliminate the denominator. That's why I multiplied by 7, to get rid of these denominators here. So it'll become 3 to 4. Then what can I do? Well, I can multiply the whole equation by 5, because both of these parts have a denominator of 5. So that would be 42 to 63. 3 times 5 is 15, and 4 times 5 is 20. So that is how you would find the ratio. Now, there are so many different ways that you can do this question. This is just one of the ways. If you still ended up with this ratio, then I'm sure that your way is absolutely fine. Okay, so this is a transformations question that kind of encourages you to think a little bit outside of the box. So I'm told that shape A is reflected in the line with equation x equals 2 to give shape B. This shape is then reflected in the line with equation x equals 6 to give shape C. And I need to describe fully the single transformation that maps shape A onto shape C. Now, the fact that it's a single transformation is going to mean that it's going to have to be, most likely, a translation, so a movement. And the fact that it is reflected in the lines x equals 2, so in the lines that are parallel to the y-axis. So if I just sketched a quick little 3, 4, 5, 6, 7, 8, 9, 10, and so forth, all of these lines, so this would be the line x equals 2, and this would be the line x equals 6, they are parallel to the y-axis. So therefore, if I had a random shape here and I translated it here and then here and whatever, it's only moving along the x-axis. Its y coordinates stay the same. But let's have a go at thinking about it with an example shape. So I know that step 1 is I have a shape that is reflected in the line x equals 2. So if I just did a quick little sketch, maybe let's do a right angle triangle. So a right angle triangle over here. It is reflected, so its original point, I'm going to just use this original point. So this original point is the coordinate 1, 0. That's the original point. And I'm going to track this point as I do all of my reflections. So it is reflected, first of all, in the line x equals 2. So what do? I reflect it like that. And this point, the original point, moves to become 3, 0. So the trick with this question is to, first of all, just lay out the axes like it would look so that you can visualize it. And second of all, you can pick any shape anywhere. You're just trying to see what happens to the movements of the shape as it gets reflected. So the movement is along the x-axis and it gets moved to 3, 0. This new shape is then reflected in the line with equation x equals 6. So this is 1, 2, 3 coordinates away from the line, so it then has to be reflected 1, 2, 3 coordinates from the line over there. So my original point is going to have to be here. I can pick the other points too. So over here, from 2 to 6, that's 4. So from 6 to 10, that would be 4. So I know that my right angle triangle is going to look like this. Okay, so this is the original shape. Then it was reflected in the line x equals 2. And then this shape is reflected in the line x equals 6. So whatever the distance is between each coordinate to the line, that's going to be the same this way too. So this is the final shape. And what's actually happened to its coordinates? Well, I only really need to think about the original coordinate because that's what I'm tracking. So it started at 1, 0, and its end point is at 9, 0. So therefore, it's been translated 8 across the x-axis. And how do you describe translations? So you describe them through a vector. So we'd say it's a translation through the vector. Now with vectors, just a reminder, the top part is your x coordinate. Well, not coordinate, the movement along the x-axis, and the bottom part is the movement along the y-axis. If it's positive, then it means it's been going to the right, or it's been going up. And if it's negative, then it means it's moved down or to the left. So what's happened to my shape is only moved 8 across, 8 to the right along the x-axis, and it hasn't moved up or down, so I'm going to put 0 there. So my final answer is a translation through the vector 8, 0. Okay, so in this question, I'm told that there are only blue counters, red counters, and green counters. And the probability that a counter taken at random from the box will be blue is 0.4. So the probability of blue is 0.4. The ratio of the number of red to green counters is 7 to 8. Samina takes at random a counter from the box. She records its colour and puts the counter back in the box. So there's we don't need to alter the denominators because everything is replaced. And she does this a total of 50 times. Work out an estimate for the number of times she takes a green counter. Okay, so we don't know how many counters there are in total, but we know that whatever red and green sum to must be a probability of 0.6, because probability always sums to 1. So red and green are split in the ratio 7 parts to 8 parts. So we need to think in total, that means there are 15 parts. And we want it to equal 60% or 0.6 or 60 over 100, however you want to work with this. So I know that to turn 15 parts into a percentage, I would multiply it by 4 because that gives me 60 parts in total. And then I can work with the equivalent ratios of the blue. So 7 times by 4 is 24. And 8 times by 4 is 32. So if I were to have these all as a ratio, I know that blue parts would be 40. And so blue to red to green would be like that, because I've made my probability sum to 1. And what do I need to do? She takes at random a counter from the box, records its colour, and I need to work out an estimate for the number of times she takes a green counter. So the probability of a green counter would be 32% or 0.32. And whenever you work out probability, you always do the probability of your chosen thing. So in this case, of your chosen thing happening. In this case, it's a green counter. The probability of getting a green counter is 0.32. And you multiply that by the number of trials, which means the number of times you do something. So in this case, it's 50 times. So we're going to do 0.32 times by 50, which gives me 16. So in this question, I am shown a triangle, ADE. Given some information about it, and I'm asked to prove that triangle ACE is congruent to triangle DBE. Now, in order to prove that shapes are congruent, I either need to prove that they have 3 sides, okay, so 3 sides that are equal, or that there's a right angle, a hypotenuse that is equal, and a side that is equal. So right angle, hypotenuse, and side. Or I prove that they have a side, angle, and side. So all of these are corresponding to the triangles, which means that the same angle in the other triangle is equal. So an equal side, an equal angle, and an equal side. And the angle has to be in between the sides. So let's say that side, it would be this angle and then that side. So the angle is squished in between your two equal sides. And the other one is ASA, where you have an equal angle, an equal side, and an equal angle. And once again, that side has to be in between your two angles, so it has to be linking them. So angle, side, angle, and those need to be the same for both triangles. So they're my conditions of congruence. Now I'm trying to prove that ACE, so this triangle here, is congruent to triangle DBE, so this one here. So do they have anything that is common? Well, we know that AE equals DE. That's been given to us. So that means that they have an equal side. Then we know that AB to BC to CD is 1 part to 2 parts. So 1 part to 2 parts to 1 part. And we need to prove that they are congruent. So I know that that line BD equals 3 parts, or you could express it as CD is worth 1 part and BC is worth 2 parts. So therefore, in total, the line BD is 3 lots of CD. And I know that CD, the line CD, must equal AB, as the ratio is equivalent. So if this is equal to 1 part, this must also be equal to 1 part, therefore they're equal. So similarly, I could express the line AC for my other triangle, this one here. AC must be 3 lots of AB, because if this is AB, 1 part, this would also be AB, this would also be AB. So that's why it's 1, 2, 3 lots of AB. And I know that AB equals CD because they are both equal to 1 part. So therefore, I know that BD, which is this line here, for this triangle. So BD equals AC, which is the bottom line for this triangle. So that's another side. So next, let's zoom out and just think about the basics that we know. Now, I know that AE equals DE. So I know that this side must equal this side. So if I just look at this as one large triangle, it makes it an isosceles triangle. So let's just get rid of this over here. So what do I know about an isosceles triangle? Well, an isosceles triangle, base angles of an isosceles are equal. So that means this angle here must be equal to this angle here. Now let's look at what we've proved is congruent. So I know that AE equals DE. So if I just draw these triangles like separately over here. So ACE is this triangle. And let's just draw a little sketch over here. So ACE, I know that this angle here and this angle, this side here, would be equal. So let's do the same for this triangle just to show you what's happening. So this one looks like that, and it's this side. So AE corresponds to DE and it's this angle here that is equal. So if you like flipped that triangle, so let's flip it, DE would be here, and it looks exactly like my angle ACE. So I've just imagined I've reflected it in a mirror. So what have I proved? I've proved that AE equals DE. Then I know that BD equals AC. So BD would be this line here. I reversed it. Originally it would be this one here, which is this part here. And AC must be equal. So I've got a side, an angle in between that, and a side. So I would say SAS. Oh, I should have said the last bit, angle EAD equals angle EDA. So therefore you say SAS, they have a corresponding side, angle, and side that are equal. Okay, so in this question, I've been given the equation of a curve, which is y equals 4x squared minus 56x. And I'm told that this curve has one turning point. Now, a turning point on a quadratic is literally, as it says, the point at which the equation or the graph turns. So you could think about it as the line of symmetry. So the turning point would be over here. That would be a minimum point. You also have a maximum point when the equation is a minus x squared. But right now we're just looking for this turning point. And we can do something with a quadratic, which is we can complete the square, and anything that is in its completed square form would look something like this, where x plus a minus b. So you should be familiar with completing the square. If not, watch the video on completing the square and get up to scratch on that. So completing the square allows me to find the turning point of my graph. Now the turning point is always going to be the inverse of whatever is in the bracket. So the x coordinate is going to be the inverse of this, and it's always going to be whatever the y-intercept is. So over here, that would be, in this case, minus b. If it was a plus b, it would be plus b. But this will make a lot more sense once we've actually completed the square and we can show it. But this is the completed the square form. And in order to find the turning point, all I'm doing is I'm going to write my x coordinate is going to be the inverse of whatever this value is. So if we had, for example, x plus 6 minus 20, the turning point would be minus 6 minus 20. So the x coordinate is always the inverse of here, and the y coordinate remains the same. So that's something to bear in mind for later. Now, first of all, what we want to do is start by completing the square. So when I'm completing the square, it just makes your life so much easier if you only deal with x squared. So in this equation, I've been given 4x squared minus 56x. So the first thing I could do is divide by 4 to just make my life a lot easier. So I take 4 out, and then that would become x squared minus 14x. And then I just have to worry about completing the square of this part here. So when I'm completing the square, what does that mean? It means I'm looking for an expression of a perfect square. Now, what do I mean by a perfect square? So a perfect square is something like this, where it's something multiplied by itself. So x plus 3 squared. What happens when I actually physically do that? I get x plus 3, and then I'd end up with x squared plus 6x plus 9. Okay, so the reason I'm using a perfect square is because it's going to give me the first part of my expression. And in order to complete the square, what I do is I halve the coefficient of x. Okay, so the coefficient of just x, I'd write it as x minus 7 squared. Okay, so that's the first part, the first thing that I do. Some working that you might want to do just to the side, just so that you can see, is actually expand it and say, what happens when I do x minus 7 squared? Well, that would give me x squared minus 7x plus 49. So simplify that, that would give me x squared minus 14x plus 49. So as you can see, I get the first part. This and that are equal. which is what this expression gives me. However, I also have an added on bit of plus 49. So when I complete the square, I just think to myself, what do I need to add or subtract in order to knock that off? Well, 49 take 49 is going to get me back to 0. The reason I do this is because this over here is technically x squared take 14x plus 49. So that's why I subtract the 49 to get me back to 0. So I have completed the square of this equation, but don't forget that I factorised it. So what I can then do is expand the brackets up again. So that would become 4 lots of x minus 7 squared, and then 4 times by negative 49 is minus 196. Now remember that the turning points, it's going to be the inverse of whatever is in the bracket. You're trying to get the bracket to become 0. So 7 takes 7 gives me 0. So therefore the x coordinate is going to be 7 and the y coordinate is minus 196. But all you need to do for this question is complete the square, because by completing the square, you show that they are the turning points. Okay, so here I've got some nice algebraic fractions. Now what's the key with algebraic fractions? Remember to add or subtract fractions. They need to have the same denominator. So the first thing that I want to do whenever I'm dealing with algebraic fractions is think to myself, okay, how can I make the denominator common? So let's just deal with this part first. We can deal with the negative 3 later. So we've got 2x plus 3 over x minus 5 plus x take 4 over x plus 5. Now, in order to do algebraic fractions, generally you're just going to bring together your denominators, and your common denominator is going to be the product of the two denominators. So your new denominator would be x minus 5, x plus 5, because you're just bringing them together, just like if you had 2 over 4 plus 3 over 6. You could turn this into 4 times 6, which is 24, as a common denominator. It's not the lowest common multiple, that would be 12, but because we're dealing with algebra, it doesn't matter. So my denominator is just going to be the product of the two denominators. And then I need to think to myself, what have I done to each fraction in order to turn it into this denominator? Well, just like over here, what I would have said is I've multiplied 4 by 6 in order to get that as my denominator. Over here, I've multiplied the denominator by x plus 5. So I need to do the same to my numerator, just like I would have done here to keep the fraction in proportion. So this would become 2x plus 3 brackets x plus 5. So I'll actually highlight it in a different colour so that you can see that's what you're multiplying by. And then if we think about this bracket here, what have I multiplied by? Well, I've multiplied the denominator by x minus 5. So I'm going to have to do that to my numerator as well. Okay, so now I've got a common denominator and some numerators that I can expand. So let's do it bit by bit. What I can do first of all is multiply my denominator. So x take 5 multiplied by x plus 5. X times x is x squared plus 5x minus 5x and then minus 25. So if I simplified that, that would give me x squared minus 25 is my denominator. And then I'm going to multiply my numerators. So I've got 2x plus 3 multiplied by x plus 5, which would become 2x squared plus 10x plus 3x plus 15. So bring it together, that becomes 2x squared plus 13x plus 15. And now let's multiply the last numerator. So I've got x take 4 multiplied by x take 5. That would become x squared minus 5x minus 4x, and then don't be fooled, don't forget about the signs, plus 20. So minus 5 minus 4 is minus 9x, and then you add 20. So we can write that all on top as one long numerator because both my fractions have the same denominator. So that would give me x squared minus 9x plus 20. Now what I need to do is I've got a nice long numerator and I'm going to want to simplify that. So I've got 2x squared plus x squared, so that would become 3x squared. I've got 13x, take 9x, so 13 take away 9 is going to give me positive 4. And then I've got 15 plus 20, so that will be plus 35 over x squared minus 25. So now I've dealt with the fractions, but I'm still left with, I need to subtract 3. So what do I do in order to add or subtract fractions? I know that they need to have the same denominator. So what I'm going to have to do, now that I've cleaned up the first part of the calculation, I'm going to have to ensure that 3 has a denominator of, or minus 3, has a denominator of x squared minus 25 in order to be able to add or subtract them. So if the denominator, if I've times 3 over 1 by x squared take 25 to give it this denominator, I'm going to have to times the numerator by x squared minus 25 as well. Whatever you do to the numerator, you have to do to the denominator to keep it in the same proportion. So that would give me 3x squared minus 25. And obviously, if we just cancelled those out, so if we did this divided by this, that leaves me with 3, okay? As long as the top, whatever's on the top, divides by whatever's on the bottom, when it's a product, then it cancels to make 1. So let's expand this and bring it all into one fraction. I've got 3x squared plus 4x plus 35, and then take 3x squared, and then negative 3 times by negative 25 is going to give me positive 75. And all of this is over x squared minus 25. So now the last part is just simplify. Well, 3x squared, take 3x squared, is going to cancel out. I'm going to be left with 4x, and then 35 plus 75 is 110. So I'm left with this fraction, which is the form that they told me that they wanted it in. And I need to work out the value of a, which is 4, and the value of b, which would be 110. Okay, so in this question, I am shown the graph y equals f of x, and I'm asked to sketch the graph of y equals f of x plus 2. Now remember that when you've got a transformation occurring within the bracket, so something is inside the bracket, we always do the inverse. So when x is being affected inside the bracket, we do the inverse. So that means we're moving along the x-axis minus 2. So each x coordinate is going to be shifted 2 to the left. So let's have a look at what's happening here. So let's start with this x coordinate. I'm going to shift it 2 to the left. So that would become minus 3. Then let's look at this x coordinate. So it's 0. So I'm going to shift it 2 to the left. So that would be minus 2. Then let's look at this coordinate, shift it 2 to the left over here. And then this coordinate over here would become 0. And we can do this strange one. So that is about 2 2/3. So 2 2/3 take away 2 is going to be just 2/3. So that will be up here. And this coordinate here, let's say it's roughly minus 1.5. So that would be roughly minus 3.5. Okay, and now we just join the curve up. So join it as accurately as we can. And here you've got your graph transformation. So the key thing is that when you've got something inside the bracket, you always do the inverse. So if it was negative 2, you'd be adding 2. So in this next part of the question, I have graph A, which is over here, this strange little graph. And this has been reflected to give graph B. So where would this have been reflected? Well, if I look at the line of reflection, that would be the x-axis. So when y equals 0. The equation of the graph A is y equals g of x. And I need to write down an equation of graph B. So let's have a look at what has been affected. Now in each of these reflections, my x coordinates, so if that one here is a mirror image of this one here, my x coordinates remain the same. So x coordinates remain the same. So therefore I know that I'm not going to be affecting anything inside the bracket. I'm only affecting the y coordinates, and when the y coordinates are affected, that's dealing with things outside of the bracket. So what's happening to all of my y coordinates? Well, let's just pick this coordinate here on my original graph. That would be -2, 2, and then its mirror image is over here, which is -2, -2. So what's happened to my y coordinate? Well, it's been inversed. So it was originally positive and now it's negative. Let's try another one. Over here, that would be 0.52, and then over here is 0.5, -2. So the equation of the graph is going to be y equals minus g of x, okay, because the graph has been reflected and all of the y coordinates are now their negative versions. Okay, so in this question, we have a vector question. We've been given a quadrilateral. I'm told that FE, the vector FE is A, ED is B, and CD is 2A. And I'm told that the point P is such that CEP is a straight line and that CE equals EP. So let's just visualize what that looks like. So CEP, it's not super straight, but hey, what can you do? So whatever CE is, it's equal to EP. And I need to use a vector method to prove that CF, so this line here, is parallel to DP. Obviously, this is not drawn to scale, which is why they don't look parallel. Now, the key thing is to remember that parallel vectors are multiples of one another. So in order to prove that something is parallel, you need to prove that show that it's a multiple of the other thing. So for instance, if vector A was 2A plus 3B and vector B was 4A plus 6B, you could factorize that to say that's 2 lots of 2A plus 3B, and therefore B is 2 lots of A. So that's how we prove that the vectors are parallel. So that's what we're looking for. So let's have a look at what's going on here and which vectors I can write as what. So first of all, let's have a look at how I can write CE. So the vector CE, remember with the vectors, all we're doing is we're like a little ladybug and all we can do is travel along the vector lines that we've already been told. So I've been told to get from CE, I'm going to go along this route. So that's going to be 2A. I'm going to have to go down this way. Now this vector going in this direction is B. And because I'm going in the inverse direction, it's going to be -B. So I'm going to write -B. And that's how I get to CE. So if I know that CE is 2A minus B, then EP must also be 2A minus B because I know that they are the same. Now I need to figure out what DP is. So let's just get rid of these lines here. So how can I get from D to P? Well, I can go along here, which is -B, and then along here, and I figured out that I know that EP is 2A minus B. So let's simplify that. That gives me 2A minus 2B. Now let's have a look at the vector CF because I'm trying to look at the vector CF and DP. So I've got DP over here. I know DP can be written as 2A minus 2B. And now I just need to figure out how I can write the vector CF. So once again, let's follow the lines. How can I get from C to F? So I start from C, I go along. So I start with 2A plus, and then negative b because I'm going in the inverse direction to the direction of the arrow, and then I go negative a as well because it's in the opposite direction of the arrow. So let's simplify that. 2a take away a leaves me with a, and plus negative b is minus b. So how can I write that? Well, CF equals a minus b, and dp equals 2a minus 2b. Now, in order to show that they are parallel, I need to show that they are multiples of one another. So what I can do is factorize this to make it 2a minus b. Once you said, so I know that dp is 2 lots of the vector CF. So I could say dp is 2 lots of the vector CF. Therefore, they are parallel. And in the last question, I have been given a regular heptagon. Now, a heptagon is just a 7-sided shape. And the fact that it is regular is really important because any shape that is regular, any regular polygon, has all equal sides and all equal angles. So I know that this side is equal to this side, 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 and so forth. And I know that each of the angles are going to be exactly the same. So therefore, if I know what the sum of the angles are, I just divide by 7. Now, using the rules of polygons, so you might have done this before when you're looking at any sized polygon, to work out what the interior angles is, you use the rule n take 2 times by 180. And what this means is, let's say you start from any vertice, you join it up to the next vertice, and then the next one, and the next one, and the next one, and the next one, and the next one. That one's a bit wonky. So why have I done this? It's to see how many triangles fit into this polygon. So that's 1, 2, 3, 4, 5. And why do I do this? Because in each triangle, I know the angles add to 180 degrees. So if you try this with absolutely any polygon, you will find that there's always 2 less triangles than there are number of sides. That's why I do the number of sides take away 2 times by 180. So that's just a little recap on that. So I know that there are 5 triangles in this shape, and 5 times 180 gives me, 5 times 180 is 900. So I know that the sum of the interior angles, so this angle plus this angle plus this angle and so forth, they are all going to add to make 900 degrees. Now I know that there are 7 equal angles, so I'm going to do 900 divided by 7 to figure out what one of these angles is. And that would be 128.5714. Okay, so I know that each little angle is going to be 128.5714. Okay, so I've just worked out the size of the angles because it's a regular heptagon and that's the information that's been given to me, and that's going to be helpful. Now, I am being asked to calculate the length of GB, which is this length here. And I'm also told that the area of this triangle is 30 centimeters squared. So if I just draw this triangle over here, I know that it's going to be an isosceles triangle because I know that it's a regular heptagon. So this side GA is going to be equal to this side here. I know that this angle here is 128.5714. And I know that its total area is 30 centimeters squared. Now, using your trigonometry, the area of a triangle is half AB sine C. Okay, so that's a formula that we use to work out the area of a triangle if it's not a right angle triangle, or if it's not one that I know the perpendicular height of. I label my triangles. So sine C, remember the big letters, they represent an angle, and the little letters, they represent a side. So I've been given the big sine C, so this is going to be C, and this and that side are going to be A and B. Now I know that they're actually going to be the same side, so I can just actually call them X and X just to make my life easier. And I can substitute. So I know the area is 30 centimeters squared. So I'd say 30 equals a half times by X, because this is these two sides, A and B, times by sine 128.5714. So then I could just simplify this. So that would become 30 equals X squared times by sine 128.5714 divided by 2, because remember, timesing by a half is the same as dividing by 2. You don't have to simplify it like this, you can just start rearranging it immediately. But then if I times both sides by 2, because I'm just trying to rearrange it now to solve X, so 60 is going to equal X squared times by sine 128.5714. And in order to get X squared, I'm going to just need to divide both sides by sine 128. So X squared is going to be 60 divided by sine 128.5714. And what does that give me? 60 divided by sine. Answer gives me 76.74288046. And the last final part is the square root of X. So that gives me 8.76030139. Okay, so now I know the length of the sides. So each of these sides are 8.76. And I'm trying to work out the length of GB. So once again, I'm going to use maybe the sine rule, maybe the cosine rule. Let's have a look at the information that I've been given. Okay, so we've got our triangle. I now know a little bit more information. So if I use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a, I can figure out what the length of GB would be. So a squared and cos a are going to be opposite each other. Remember, you can label your triangle however you want. So if this is the big A, this is going to be little a, and this are going to be B and C. It doesn't matter which one's which. So a squared is going to be 8.76 squared plus 8.76 squared. Take away 2 times 8.76 times 8.76 times by cos 128.571. So let's just clean that up. 8.76 squared plus 8.76 squared gives me 153.4752, and I'm going to subtract 8.76 times by 8.76 times by cos 128.571, which gives me minus, did I do times 2? Sorry, I don't know what I did. Nope, times by 2. That gives me minus 95.689345. So a squared is going to be 153.4752, take away answer, which is 249.164525. Remember that because you're subtracting a negative, you're actually going to end up adding it. And then if a squared is that, then a is going to be the square root. So the square root of answer is 15.784. 15.784, and it says correct to 3 significant figures, so that would just be 15.8.